So we're continuing with objective 4. We're discussing the future trends in animation and game design. We are now at gesture base. We already looked at the trends for virtual reality, the trends for augmented reality, and we're going to finish off with gesture base animation, gesture based games, and so on. So Zane, you want to start the reading for us? Let me see. Oh, you can read it up to the end of smartphones.
Alright. Gestural UI refers to using specific gestures, like scrolling, pinching, and tapping to operate an interface. Currently, smartphones and tablets are the most common place everyday consumers can find gestural UI. From Apple iPhones to the Samsung Galaxy, the vast majority of contemporary phones incorporate some elements of gesture UI, from swiping and scrolling, which is common to most phones and tablets, to orientation recognition. The Samsung Galaxy S4 is an example of one smartphone that has taken gesture UI a step further. The phone tracks and recognizes your eye movement and automatically scrolls down as your eyes reach the bottom of the page. Current research and experimentation suggests that in the future, gestural UI in phones and tablets will use more cameras and sensors, increasing responsiveness and recognition capabilities. Experts assert that phones and tablets will not only be able to understand non-touch gestures and facial expressions, but will be context aware, meaning these devices will be able to anticipate and predict what users want to greater degree of accuracy than is currently possible.
Good. So gesture based is basically movement, some form of movement that is mapped to some form of action on a device, whether a computer or some sort of system. So, like for example, our smartphones, when we swipe up, when we swipe down, it moves whatever is on the screen. Um, some phones they can track your eyes, like the Samsung S4. I think I'm not sure about the newer models, but those versions they would have tracked eye movement. So when you look up, when you look down, it would basically move the page in that direction. Do you guys know of any other gesture controls that phones have?
Some phones, when you shake it, it like comes on.
Good, good. That's one.
I know with well, I observed from Daddy's iPhone that whenever he picks it up, it automatically comes on.
Good. Um, they developed a company developed a phone that when you squeezed it, I think it's one of the LG phones, something would happen. There were other phones that would have basically if you put your hand in front of the camera and you move it in a certain way, it would track that movement. Like for example, if you position your hand like you turn in a knob, like if you turn in a volume knob, it would actually control the volume. So if you turn to the left, it would go down, you turn to the right, it would go up. So those are implementations of gesture. So it's not only for smartphone and tablets, but you're gonna find it more commonly in those devices.
So, sir, there's this camera that when you can place it like on a table or so, and whenever wherever you move, it moves along with you. Is that gesture based as well?
No, that's more of tracking.
Tracking.
Yeah, that's tracking you to basically put you in the center of the camera, so that you're in focus with the camera. Gesture would be if you move your hand um, to a certain direction and the camera moves in that direction, but then technically it's like a gray line area because um, yeah, but that's more of tracking. That's more of tracking. The camera is tracking you where you are moving. It's not that you are doing something specific, like making some sort of general movement with your hand or your fingers or your body. It's just you generally moving. So that's just tracking you. But if you were to like move your hand in a specific direction, and the system, the camera would move in that direction, then that would be gesture. All right, so gesture in gaming now. Alia, you can read that.
Gaming is another area where gesture UI is already commonplace. The Xbox 360 and Xbox One consoles, for example, use the Kinect system to track player movements via cameras and sensors. The PlayStation 3 and 4 consoles use PlayStation Play in a similar manner, while the Nintendo Wii and Wii U use motion sensors and remote controls to track player gestures and movement. The future of gestural user interfaces in gaming includes the use of gesture capable touchscreens that wrap around gamepads for greater gaming control, particularly for 3D gaming. Additionally, according to Microsoft and Sony, their vision for the future of gaming includes the combined use of gaze tracking, gesture recognition, and brainwaves or technological telekinesis for a far more immersive gaming experience that borders on virtual reality.
Good. So gestures in game, based on the movements you make, you can basically interact with the game, or you can basically move a character in the game. So like for example, the Nintendo Wii system, they had the game, the Wii Sports, which you could have used the remote as a gesture. Whenever you move the remote, it would move the character in the game in that um, with those similar movements. But with newer form of gestures, they want to do gaze tracking, recognition, even brain form. So basically track maybe what you're thinking, or track your brain patterns. I think I think I read somewhere some article that Elon Musk, he is close to having some form of technology doing this here, brain tracking. You know those systems whereby you can have it connect to your is what do you call it? Your the part of your brain that basically it senses the movements, or you can think of something and that signal is being sent. Well, there's a technology that can be attached to those parts of your body, and the system is going to recognize those signals and make the necessary movement in whatever it's connected to, whatever system it's connected to. So all of that is possible in games and other technologies. So in medicine now, how is gesture being used in medicine? Zain?
In the world of medicine, the feature of the gestural user interface is very promising. One of the most notable innovations is the introduction of gestural UI in surgery. Plans include a hand gesture recognition system that enables surgeons to review images and patient records during surgery. The ability to manipulate the interface via non-touch gestures reduces surgery time, as surgeons won't be forced to exit the operating theater to access traditional computer terminals. The biggest benefit is the potential for the reduction of the risk of infection. If surgeons can manipulate UIs without having to make physical contact, the risk of passing harmful bacteria to the patient is greatly reduced. Still in the development stages, robotic scrub nurses will operate based on the same gestural UI and could conceivably take the place of a human scrub nurse in a range of medical functions, thus increasing the potential to improve surgical outcomes by reducing the likelihood of human error.
Good. So how can gesture benefit us in medicine?
reduces the risk of bacterial infection.
But how?
Uh,
Practically, how? How will the system function or work that it will allow us to reduce that those risks? So in the first place, what do surgeons have to do to minimize the passing of bacteria and other diseases and so on? What do they have to do?
Sterilize their equipment.
Good. So sterilize the equipment and sterilize themselves before they go into the theater room. Now, if they want to read a patient's file, they want to, during the surgery, they want to look at the patient's record, then they have to come out of that room and operate a system to look at the person's information. Now, with a gesture-based system, that system could either be in the same room or another room, and they can gesture to the system so that they can use the system instead of actually physically being in contact with the system. So thus, they don't have to leave the room to use the system, to touch the system. They can just interact with the system from a distance, and that basically it reduces time because they don't have to go and sterilize themselves once again to continue working or continue operating on that patient. So that's one benefit there among all the rest. Where do we commonly see gesture-based UI? Alia?
The mobile device market isn't the only industry that's already using gesture based interactions. Gesture UI is also commonplace in the gaming, automotive, and medical industries. Popular consoles such as Xbox use cameras and sensors to track player movements and gestures for many of their interactive games. Automotive engineers are integrating GUI interfaces in their driver information displays to change temperature and volume by making a touchless gesture in front of the screen. Jaguar Land Rover, for example, teamed up with Cambridge University to develop a gesture reading system in response to the COVID 19 pandemic. In the new normal, once lockdowns around the world are lifted, a greater emphasis will be placed on safe, clean mobility where personal space and hygiene will carry premiums. In hospitals, gesture based UI is being used to help doctors and surgeons view images and records without having to step foot out of the operating room. These are just a few of the many industries that are exploring all the benefits that this can provide for its customers.
Good. Any questions, comments? So we can see how gesture-based interfaces are being used. So in automotive, in the vehicle, as you focus on driving, you don't have to go and worry about turning knobs or so on. You can gesture, make a quick gesture, so that you can interact with the system. Maybe to turn off the volume completely, you can raise your hand. So that's like in the camera on phones. When you raise your hand, you can take a selfie. So maybe in those systems, you can raise your hand to like stop the music, or you move your hand to change the temperature. That can also work to minimize interaction. So why touchless gestures matter? Zain?
Consumers' attitudes toward public touchscreens have quickly changed since the COVID-19 pandemic started. Now with social distancing and hygiene being top of mind, there is further need for touchless devices, as more consumers now fear having to physically touch screens in public areas. In fact, Experts have already noticed a sudden decline in fingerprint technology shipments worldwide due to hygiene concerns. The demand for touchless options to pay for items at the grocery store, access money from a banking machine, or sign for packages has already started to fuel the future of touchless GUIs. The evolution of GUI technologies have also improved UX design and development processes in general. Previous UI interfaces quickly become a huge source of frustration for customers. Low quality touchscreen on smart devices created poor response times and precision, faulty fingerprint scanning, and even damage from wear and tear. Today, consumers want higher quality touchscreens with better graphics, faster response times, touchless GUI designs that are far more hygienic and convenient to use. Advancements in displays, cameras, and sensors over the past few years have opened the gateway for better experiences for consumers and developers alike. For example, a recent update to the Google Fit app allows mobile device users to measure their heart rate and respiratory rate to track day-to-day wellness and all using the device's camera.
Good. So, what is one need that persons have for gesture-based UI? Or why are persons interested in gesture-based UI?
To avoid unnecessary contact with public spaces
Mm-hmm. Why do you want to avoid that?
because of the fear of COVID-19 pandemic.
But
So
is
just mainly want to pay for items at the grocery store, sign for packages.
is it only for COVID, or is it only because we have COVID?
No,
No, it's for less contact in general because COVID is not the only disease. The common cold, and other diseases that can be transferred by touch. So it's going to be useful for public areas to restrict using touching surfaces in public areas because, like for instance, like an elevator. If you think about it, look how many persons touch um, buttons on it. Look at doors. Look how many persons touch the handles on doors. So even those automatic doors is gesture based because well, it depends on. No, technically that won't be gesture based because you're just walking up to it and it's just detecting you. But if a system whereby they can implement that you wave at the door or you put your hand at the door at a certain distance and it detects you and you a door opens for you, that's going to be a useful technology. You no longer have to touch the surfaces anymore because we don't know who has what bacterias and what disease, and it can be left upon the surface and then it can be transferred over to you. So it's a more health-wise system to help with hygiene so that persons who have concerns in those areas they don't have to basically deals with those negative things.
And sir, like those stuff like the automatic hand sanitizer and the
Good,
hand dryer.
good,
That's
good.
it. That's gesture based as well.
I'm thinking it. Rama said it's like a gray line area because I thinking you can't consider them gesture based because you just appearing there. Yes, it's tracking you because remember gesture based has to track you also. So yes, I would say they are gesture based because you
Well,
walking up there.
I don't
Yeah,
think most of the hand sanitizer. I think it'll be for like the dryer.
right.
Cause like as soon as you put it, it does come on, but then when you move away, it does come off.
Well, it could just be the technology that was used. The hand sanitizers one, they're a little more not that advanced. because it does take a while to give you your hand sanitizer, but it could be just because of the company that designed it. It wasn't that good at tracking whoever is there, so that's just why it takes a while. But other than that, it's still a form of gesture, I would say, that you're putting your hand out there and it's detecting it and it's going to perform the necessary action. So you don't have to physically touch the hand sanitizer or the dryer anymore. Or even some pipes. The faucets, they have a gesture system. You just put your hand and it detects it, and the water comes on also. Good. So we have the idea of why gesture-based systems are basically interested to persons today. So the future of embedded gesture-based UIs, I think, Alia.
Experts believe that we are only at the tip of the iceberg regarding the gesture capabilities of embedded GUIs. As the technology evolves, we can expect to see improved responsiveness, moving towards the ability to predict what users are going to do before they even do it. The gaming industry is already developing GUI enhanced software that utilizes gaze tracking and telepathic based science to create better virtual reality experiences. The medical industry is moving towards highly advanced UI um, devices for high risk environments that will reduce the transmission of germs and bacteria and speed up necessary processes. There is no doubt that the demand for gesture based GUIs is exploding, as well as the technology around it. Developers and design teams that are integrating these technologies now are already starting to get a leg up on their competition. For any embedded GUI team, now is the time to start putting touchless gestures into your development framework.
Good. So another future of gesture-based UI is predicting the person's movement. Because remember, the gesture, it has to track the person. So over time, if they build like a database, a AI system whereby they're tracking persons, remember persons are going to make like similar patterns of movements. So they can have a system whereby they're tracking persons and recording what is the pattern of their movement, so that the system now can basically predict what might be the next movement, and that way now it's a more enhanced system that they don't have to wait on that delay of looking at the person and waiting to see what they're going to do. They already know what they're going to do, so that case now the system is going to be a little faster, more efficient in terms of responsiveness. So creation of animation through gestures.
Performance animation is a computer sciences branch that studies real-time 3D models animation. With this type of animation, it is possible to express human gestures through anthropomorphic models, or alternatively map a human gesture to an event in a 3D scene. It can be used in different contexts: puppetry, navigation, and interaction with 3D scenarios. This system allows the connection of the sensors to the elements of a 3D scene. Thus, the animator can interactively find the gestures that the model makes possible. This immediate feedback lets the animator synchronize his actual movements with the synthetic movements on the scene. In puppetry, the greater is the number of the gestures the character is able to realize, the more it appears natural, and consequently is easier for the animator to make it more press it.
Good. So I think we covered this a few times already. Um, Basically, we have a 3D model, which is basically going to be a person, and we track the movements of that person, the gestures that person would have made, and then we map that now to some form of animation so that we get a animated character moving. So we don't have to do the actual animation of the character. The 3D model is going to do the movement. So that person is going to do the movement, and they map that movement now to whatever character they are trying to create, or whatever scene they're trying to create. You guys get the idea?
Yes, sir.
See,
All right, pointing and clicking, Alia.
the ease and functionality of mobile devices is shifting the way we think about interactivity. Smartphones, tablets, and laptop hybrids are ushering a new age of UI that favors a more direct form of interaction, one where mouses are optional. While a few years ago you could chalk up mobile devices' popularity to being new and different, today we're forced to admit there's something else behind their lasting success. Users are finding that the control system of gestures made viable by animation are more than merely entertaining, they're useful.
Okay. Zayn, continue reading.
A study by Dan Moine, director of human factors and research at Human Centric, shows us that gestures might be more intuitive than we once thought. According to the notes by Luke Robolewski, the study asked 40 people in 9 different countries to create gestures for 28 tasks, like deleting, scrolling, zooming, etc. While this is a topic worthy of its own article, the important thing to note here is that the gestures tended to be similar across culture and experience. For example, when prompted to delete, most people, regardless of nationality or proficiency with mobile devices, try dragging the object off screen. The differences between cultures and familiarity with touch devices was slim, although the Chinese seem to offer favor symbolic gestures. The biggest differences arose in scrolling, where some gestured up and others gestured down, depending on which mobile device, if any, they were more familiar with.
Good. So they're trying to implement gestures for everyday tasks, editing, moving objects, deleting them, changing formats, and things like that. So they gave the example of deleting, and one of the common gesture for deleting is dragging something off of the screen. Now, if you think about it, it actually makes sense because if you drag something off the screen, it's like if you're throwing something away. So they try to put the gesture in such a way that it's like something we can compare to realistically. If we were to throw away something, it's like if we are deleting it basically. So we have some gestures here. We have tap, double tap, drag, flick, pinch, spread, press, double tap. So even on your keyboard, your keypad, your trackpad that you have on your computer, you guys ever tried double tapping on your keyboard on your trackpad?
Yes, sir.
Press with 2 fingers, swipe with 2 fingers, pinch with 2 fingers. This is what I'm doing right now. I'm pinching with 2 fingers. I'm spreading with 2 fingers. So that allows me to zoom in and zoom out easily. One finger moves the cursor. But if you do 2 fingers, you can scroll up and down. If you do three fingers, this happens. You guys can still see that?
Yes, sir.
Yeah, if you do three fingers, all of that is possible. It switches between windows. So all of that is gesture. And it actually makes using your computer a lot easier because I don't need to use the keyboard or the mouse to scroll. I can easily use two fingers to go up and down. If I want to see something more clear, I can pinch in and see the information. If you double tap with two fingers, you get the right click. So it makes using a system a little more easier on you. So continuing the reading, Alia.
What this tells us is that gesture based control seems to come naturally to us, or at least can be picked up quickly. If that alone isn't reason enough to embrace it, let's take a more practical look. Less clutter, as if the size limitations on mobile devices weren't bad enough. The common lack of a keyboard means often the UI control panel is squeezed onto the screen, sacrificing valuable content space. But the more an app or site relies on gesture controls, the less buttons on screen and thus more content, more fun. While this may not seem like a practical factor in making a business decision, the fact is people will choose a fun app or site over a slightly more useful one. More potential. Every corner of mouse pointing and cooking has pretty much been explored by now, and it's rare to see something new with it these days. However, gesture controls are still very much new and exciting and can be interpreted in many more ways. With a little ingenuity and imagination, you can create something no one's ever done before. If you have doubts about it, just look at the diversity of touch based video games.
Good. So have you guys ever found that touch gesture controls come naturally to you?
Yes, sir.
That you don't have to get somebody to train you to gestures. It just comes naturally to you because the my trackpad, I did not actually know it was gesture based, but it's just by randomly pressing my fingers on it and moving my fingers, I realize I can do all of these things, and it just comes to you naturally. That it came to me naturally that I could move my fingers in these different ways, and different things were happening. So that is like one of the driving force of using gesture based UI because of how natural it comes to us to use it. Um, for example, on your phone, when you're watching a phone with the video player, you guys ever realize that the video player has some gesture controls on it?
Yeah, it's possible to zoom in.
Right, right. It's two other main gestures: the brightness control and the volume.
Yeah.
When you swipe on the left, it gives you the brightness control, and when you swipe on the right, it gives you the volume control. So you don't have to pull down from the top now and pull down from the notification bar and move your brightness slider. You don't have to press the button on the side to volume up and volume down. You can quickly do those gestures. And as you mentioned, if you want to zoom in, you can zoom in, pinch the screen, spread the screen, and you can easily zoom in. So it makes using our device a lot more easier.
I only experience it with Netflix. Like on the tablet, you get a part where you could, on the left hand side, you could tune the brightness by
Okay.
going up or down.
The video player on your phone. It's only work with the video player on your phone. Not like if you're watching a YouTube video, it won't work. But the actual video player on your phone, it works with that. If you try, even if you download VLC or any other video player, like for example VLC, it works with that also, the volume and the brightness sliders. Alright, continuing, Zin. To be fair,
To be fair, there are downsides to gestures. As Thomas Hughes, managing partner of Little Miss Robot, points out, one of the biggest drawbacks to gesture controls is the learning curve. Because there is so much potential and room for interpretation, gestures can also be confusing, especially when users switch between devices with contrasting controls. In fact, the more you rely on gestures over visible buttons, the greater the responsibility for confusion. There are several ways around this, but Max Rodberg, co-founder of Alibaba, advises against walkthroughs. In a post titled, "If You See a UI Walkthrough, They Blew It," he explains that too much information at once might lead to more confusion. The safer option, then, is to explain the trickier gestures slowly and over time, preferably with subtle visual cues instead of flat out explanation.
good. So we have a disadvantage here. Yes, it is easy to gesture, and we try to make it easy by using similar gestures on all devices. So, like on most devices, when you spread your fingers, you zoom in, and when you pinch, you zoom out. It's the same on your phone, the same on the computers. They try to make it similar so that the gestures are easy to remember. When you scroll, when you swipe down, you scroll. When you swipe up, you scroll also. So they try to make it familiar. But as you get more advanced, when you start adding more gestures for different options and features and so on, that is when it can start getting technical. That's when it can start getting difficult because persons might not remember what gesture do I have to do to turn on the volume, what gesture do I have to do to open the door. So if we don't like have a standard, or if it is like a new setting or a new feature that we're going to use, then obviously it's going to be a new form of gesture. And you have to remember too also that companies, they don't usually always work together. They don't standardize gestures. They might not standardize all gestures. So one gesture in one system to control volume might be to imagine you're turning a knob, and in another system it might be just simply flicking your hand up or flicking your hand down, or just raising your hand or raising your hand down. So it can be difficult at times to learn if there is no standard gesture and if there is new gesture controls that were introduced. Any additions or questions?
No, sir.
All right, so the last section, animation, completing the illusion.
One of the main reasons gesture controls feel so natural and intuitive to us is because they resemble interacting with a real object. To throw out a used tissue, we select it, move it over the trash can, then release it. As discussed with Web UI Patterns 2014, that interaction is just more satisfying than a traditional drag and drop option. But in order to recreate these lifelike sensations digitally, well excused animation is no less than necessary. When paired with gesture controls, animations essentially trick the brain into thinking, at least somewhat, that it's interacting with something tangible. So when animations visually mimic the real life reactivity to our gestures, we become that much more immersed in the experience. But be careful, because this works both ways. One false step, and the illusion, along with our immersion, is shattered. Simulating realistic responses digitally is by no means easy, but when done correctly, it's rewarding. Rachel Hinman, mobile UX researcher at Intel, compiled a list of the 12 basic principles for animation, taken straight from the 1981 book, The Illusion of Life Disney Animation, but adapted to mobile design.
But so, what is the key factor for gestures that makes it so intuitive, that makes it so interesting? What is the key factor behind it?
Sir, it represents like interacting with a real life object.
Right. It represents like if you are actually interacting with something. So that's like the example with the phone that when you want to turn the volume, it basically told you to imagine like if you're turning a knob to position your hand in the same way, and it feels natural because it feels like if you're actually turning the knob. So the gestures, they try to make it realistic. They try to make it like if you're interacting with a real life object. But as the paragraph mentioned, when we are doing gestures for animation, um, the immersion, the realisticness of that animation is going to depend upon the um, how comparative it is to basically what is real. So if the animation does not compare to something we do realistically in an everyday basis, then it can either in our mind be considered a good animation, that it was a realistic animation, or we can see that it was something that was we're gonna say that it is basically fake because it's not natural to us. So when it comes to animation, when it comes to games, when there is any form of gesturing in the animation or the game, it has to be natural, it has to be realistic in order for us to basically enjoy it. Otherwise, we can always say that this thing look fake and we won't enjoy what we are looking at basically. So that is why this person here, they looked at Disney's methods of animation or gestures, and these are the 12 methods of gesturing that would seem realistic to us. So that if we carry out these actions, it basically matches what happens in real life, what happens in a real world scenario. And if it happens this way in an animation or a game, we can perceive it as being real and it's going to be more enjoyable. So, um, we have squash and stretch. Be mindful of an object's mass and rigidity displayed by how it squashes and stretches when moved. Will your object move as a solid block, or will it display some flexibility? So, like when you're animating, say this is the ground here, and you have a ball, will the ball go like this here? It's supposed to be the same size, but I can't get it to go the same size. But just imagine it going at the same size, then you won't see like a realistic kind of bounce because there is no squashing and stretching. But if you see something like looking like it's going something like this here, let me draw another one like this, and this one is going to be like something like this, and then basically a flat in here, and then it comes back up, something like that. Then that's squashing and stretching. That's going to make it a little more realistic than what you're seeing on the left hand side. So something like if the if a ball was coming down, you can start stretching a bit, and then it's gonna flatten, something like that, and then it's gonna bounce up in the other direction, something like that. So using that method can make your animation a little more realistic, but it all depends on the mass of the object. Is it something that has a lot of mass, then obviously it won't move. But if it's like something like a ball, a flexible ball, then you have to basically animate that flexibility. Anticipation, visually anticipating the next action can help alleviate some user confusion as well as make the UX more enjoyable. So basically putting something that would give an idea of what could be possibly the next scene, like maybe a shadow or some form of silhouette or some form of light shining in the direction, something that would give you some form of anticipation of the next scene. Staging, presenting your content properly will help anchor your user so that they feel more comfortable interacting with your app. Straight ahead and pose to pose. Use straight ahead animation to capture dynamic and complex movement. Pose to pose to cover more predictable movement. What we're gonna do, we're actually, I think we should look at some content on these here. So what you guys can do as an activity, um, get some images of each one of these different principles that are used for animation so that you get a better idea as to how they function. So you can work together in your groups once again and get some images as to how those principles actually work. So some additional work there. Any questions before we conclude?
No, sir.
Awesome.
All right. So let me stop this recording.